Assalamu alaikum. By the end of this video, you will be able to understand the following two representation of functions. One is roster form and another is graphical representation of functions. Let's begin. Representation of functions are of four types. One is arrow diagram, roster form, graphical representation and algebraic representation. Among these four, arrow diagram is well explained with Arabic translation in one video and algebraic representation is also explained in another video. So for these two you have to watch another video. So in this video you are going to learn about the roster form and graphical representation. And here are the few important terminologies of function with Arabic translation. Make a note of it. And now we are going to learn about the roster form. Roster form. In this representation, functions are represented by listing the order pairs and are enclosed within the curly brackets. Order pair. What do you mean by order pair? Ordered pair means if it is written like this 1, 2, 3, 4 like this and it is enclosed in the curly bracket. This kind of representation is called roster form. So let me take an example of function from a previous video on arrow diagram. So this is an example. This is the representation of function on arrow diagram. So this also can be written, the same function can be written in the roster form. See here, f equal to, open the curly bracket. Now here you can see A maps with 2. So this can be written as A, 2. Right? So next one is B, 5. B is mapped with 5. And C is also mapped with 5. And the element D which is mapped with 7. So this you have to close in the curly brackets. This you have to close in the curly bracket. This representation of a function is called roster form. So here the functions are defined as set of first order pairs with the property that no two order pairs have the same first component. This is important. This is important, that with the property that no two order pairs have the same first component and the different second component. If it's the case, then it is not a function. Okay, so here very simple. Now here in this one, the domain is the set of first component, that is A, B, C, 5. Same thing here. These first set elements are the domain, that is A, B, C, D. The set of first components is the domain and the range is the set of second components, that is 2, 5 and 7. 5 is repeating, so no problem, just you have to write one time, that is 2, 5 and 7 is the range. In this example, 2, 5 and 7, 2, 5, 7 is the range, and A, B, C and D is the domain of the given function. So let me understand by doing an activity. Here, which of the following are functions? If it is a function, write domain and range. If it is a function, okay. So here, these are the three example problems. Now pause the video and solve it. Find the answer for it. Okay, I hope you did. Now let me check. Now check your answers here. The very first one is check for the first component 2, 3, 4 and 5. These all four are different. Then it is a function. Simple. First components are different means it is a function. It is a function. It is a function. You can write it is a function. Then if it is a function, then you have to write the domain. What is the domain? Domain of this one is 2, 3, first component elements 2, 3, 4 and 5. And the range of this one is, check the answers, I hope you did. The range is 4, 6, 8 and 10. Second component elements 6, 4, 6, 8 and 10. These are the range of the given function A, given function f, question A. Now for the B, you can see here, is it a function or not a function? First check that one. Here 1, 2, again 1, then 5. So is it a function? Yes, you are right, this is not a function, because the first component, that is 1 and 1, is getting repeated here. So first is repeating, means it is not a function. It is not a function. You can write the answer here. It is not a function. Now check the last example here. Now check the first components 2, 3, 4 and 7. All are different. When all are different, then it is a function. You can write it is a function. It is a function. When it is a function, then you have to write the domain. The domain of this one is the first component elements, that is 2, 3, 4 and 5. This is the domain, and the range of this one is second component elements, that is 3, 4, 2 and 7. So you can write in ascending order 2, 3, 4 and 7. So this is the range of the given function. I hope it's clear for you. Next representation is a graphical representation. In this representation, we will identify the graph that represents a function or not a function by using a vertical line. This kind of straight line is called a vertical line. So now you see a graph over here and see the vertical line. If it's touching only at one point, wherever you see it's touching only at one point, right? It's touching only at one point, then it is a function. If it's touching only at one point, then it is a function. If it is touching only at one point, the vertical line, if it is touching only at one point, then it is a function. You can check it. It is touching only at one point, given one point, then it is a function. Right? Just you check it. It is touching only at one point throughout the graph, then it is a function. One more example you can see here. So this is another function. Here again you see a vertical line. How it is going slowly. Just here it is touching only at one point for this graph. So this is a function. But whereas if you check this one, see here the vertical line is touching at 2 points. It is touching at 2 points, right? So this, if a given line, if touching at 2 points, then it is not a function. So this is not a function. Right? So this is touching at 2 points. Check it. This is touching at 2 points. Therefore, it is not a function. Another example. See here. Another example if I take here. Here this is a function. This is not a function because it is touching at 2 points, right? Here and here, 2 points. Now the same straight line, just to make some ruler on your page, you can check it. So this is touching at 1 point. Therefore, this is a function. So same thing you can check over here. So if here it's the same ruler, if it's going straight line like this, it will touch only at 1 point. This will touch at only 1 point, right? Straight lines only 1 point. Therefore, it is also a function. But whereas if the straight line, if you go like this, it is touching at 2 points. So this is not a function. And this is a function. You can check with a scale or ruler in your book. So here the first one is a function, second one is not a function, third one is a function, fourth one is a function, fifth example is not a function, and sixth example is a function. It's very simple. Just you have to check with the vertical line. Just it's going like this straight line. If it is touching only at 1 point, then it is a function. Simple. Right? So another thing in the graphical representation is to identify one-to-one function. by using the horizontal line test. So what is the horizontal line? This line is called the horizontal line. So by using the horizontal line, we will identify the given graph is a one-to-one or not one-to-one function. For this, just use the ruler or scale or your pen. Just check it like this. If it is touching at 2 points, anywhere, this is a horizontal line, but this function is touching at 2 points. Therefore, it is not one-to-one function. Not one-to-one function. If a ruler touching 2 points on a horizontal line, then it is not a function. Now you can check here. This is a straight line, horizontal line. Anywhere, is it anywhere touching 2 points? No, nowhere is touching 2 points this graph. Then this is, so example 2 is a one-to-one function. Example 2 is a one-to-one function. So very easy to identify the graphical representations. So one more examples here. Anywhere you draw the straight line, anywhere, is it touching 2 points? Yes. The first, here it's touching 2 points, here also touching 2 points. Therefore, it is not one-to-one function. It is not one-to-one function. Now see the last one. Here, is it touching anywhere 2 points? Anywhere in the graph? Anywhere? Nowhere, right? So everywhere the horizontal line touching only at 1 point, then it is one-to-one function. This is one-to-one function. I hope it's clear for you. Two representations we have finished here. One is arrow diagram. These were the basics of roster form and graphical representation of functions, and I hope you understood. To go more deep into functions, watch the videos Functions and its arrow diagram representation with translation, with Arabic translation, and algebraic representation of functions with Arabic translation, and composition of functions with Arabic translation. Link is provided in the below description box. Thanks for watching. Have a nice day. Masalam.